I'm standing in front of one of our measurement trees where during the season we monitor tree growth, vegetative growth and fruit growth. We also monitor fruit size, fruit maturity. But the ribbons I want to highlight today, we've individually tagged a group of shoots and we come along at regular intervals, maybe every 2 to 3 months, and monitor shoot length, and that's one of our indicators of vegetative growth, and we use that to assess tree growth and development compared to the other experimental treatments. So these trees have all got different crop loads, different fruit per tree, and as I said, we come along and regularly measure shoot length. We also monitor the main leader length as well in each of these so-called measurement trees. I'm going to today demonstrate how we use a tool called a septometer, which is basically a light meter to measure light interception in our tree canopies. This device has a number of sensors along the bar, and we use that to measure our tree size, our canopy size at certain times of the day. And we normally pick clear sky conditions, but today's demonstration was just for demonstration purposes. We have a lot of cloud about. So what we do normally is have a reading in full sun in the open area of the orchard and record that, and then we measure the shaded area of the canopy that we're interested in. And as you can see, it's really nearly solar noon at the moment, so the sun's directly overhead and the shaded area is quite a small area directly under the canopy. And to make those measurements, we come along and we do our spot measurements along the canopy and record the data. And we're doing that on all our experimental plots and our experimental treatments throughout the orchard, throughout the growing season. And that gives us data on canopy size, canopy structure, and light interception. And we can relate that to productivity, yield, fruit quality, and other attributes. And basically it's a handheld device. It's a light bar, 80 individual PAR sensors. PAR stands for photosynthetic active radiation, and it's the spectrum of light that plants and crops use for photosynthesis. And basically this tool is you can do the individual readings or the entire bar average readings, which is what we use, and you do spot measurements and record the data.
Hi, I'm Dario Stefanelli from Agriculture Victoria, currently in the Stonefruit orchard at Tatura, and I would like to discuss with you one of our main part of the experiment, that is to identify what are the different treatments that we are currently exploring, that is canopy shape, canopy architecture, and fruit crop load would do to the maturity of the fruit and the variability within the canopy. So as part of the experiment we use the DA meter and we collect a certain number of fruit, at least 5 fruit from the top part of the canopy non-destructively, so we can go and measure it regularly every week, like similar to what I'm actually currently doing. So non-destructively we take the measurement of a DA meter in 2 different and opposite cheeks of the fruit, and we take a certain number of fruit at the top, and then we measure similarly the maturity in fruit. Again, 2 measurements at each side, 1 measurement each side of the fruit cheek from the bottom part of the canopy. In this case you are in front of a Tatura trellis, and so we measure 5 fruit at the top and 5 fruit at the bottom from each branch of the tree, so the opposite 2 V sides of the Tatura trellis. And we have currently 24 trees in plot that we measure, and so as you can understand is quite a bit of fruit numbers that we are collecting, fruit measurements, and in this way we will be able to really identify the gradient, the maturity gradient between the top that passes in the middle of the canopy and then to the bottom, to be able to determine a correct protocol of harvesting, of optimal harvest. If we identify what is the gradient, then we are able to identify when to go and pick up and harvest that fruit correctly.